Hi everyone, this is Sam Gabriel, and in today's video we are going to look at how to deploy Databricks onto Azure using Terraform. So I have a demo set for you, and we'll explain in the demo how this is done. I'm going to go through the code and show you how you can automate the process of giving your developers access to Databricks and notebooks and creating clusters, scaling those clusters, auto-scaling those clusters all through Terraform. So it's a repeatable process, and you can create it, you can destroy it when you're not using it, so you can save a lot of money that way. Okay, so let's go ahead and take a look. So what I'm going to do here, just to save some time, is I will commit this code into GitHub to get Terraform to automatically provision the resources. So why don't we go ahead and do that? So let's just say first run. And I'm going to push it. So while the Terraform plan and apply goes through, what we'll do is I'm going to explain the actual code itself. So let's go ahead and take a look. So you can see the Databricks Azure Workspace in Terraform Cloud. It's already in the planning phase. And while it plans, I just want to walk you through a couple of variables that will actually make this fail because we have a policy in place. So the key two variables that I'll talk about here, the other ones I'll discuss later, but the key two is the first one, node type ID, and you can see it's I specified it as DS5. So that's the type of the VM that will get generated by Databricks in Azure. So it's going to call upon an auto-scaling cluster using these VMs as worker nodes. So in the policy that we specified inside of Terraform using policy as code with Sentinel, we said only allow standard DS3 and DS4 to be the list of VMs that you're allowed, or VM types that you're allowed to deploy. So that way you have some guardrails in place for your development teams to be able to consume these specific types of VMs. The other one here is the maximum number of worker nodes inside of a cluster that gets generated by Databricks. And we have it capped at 5. And I put 10 in here once again so we can see the effect of the policy that will fail. Let's go ahead and look at our run. This is our first run that we just pushed. The plan succeeded. The cost estimation phase is a phase where we'll do our best to find out how much resources are going to cost when you deploy them. In this case, we usually talk to the Azure API billing, the billing API in Azure, to figure out what the list price is for the different resources you're pushing or you're deploying. In this case, because Databricks is the one doing that behind the scenes, we're not able to see it directly. Now, policy check soft failed. This is a soft mandatory check, meaning that you can override this policy if you wish to do so. So the failure here, if you look at the print messages, Databricks cluster shared auto-scaling, the maximum number of workers has a value of 10 that is greater than the value of 5 that we put in place. The second issue here is with the VM type. As you can see, we said DS5. We're only allowed to deploy DS3 and DS4. Okay, so you have a couple of options. We can override this and continue. You can write a note here. So maybe if you need to get approval from a team member or upper management, you can write that in here. Everything is audited, and you can go ahead and override the policy, and you can deploy your code. So I'm going to discard this run for now. You're going to go ahead and change the variables to the proper ones that we're allowed to do. So this will be DS3. And let's save that. And the maximum workers, bring that down to 4. Save that variable. Now I can commit and push once again from my Visual Studio Code, or I can just queue the plan from here. So I'm going to queue the plan. And while this runs, let me go ahead and show you what the actual code looks like. So we have a couple of Terraform files. It's very simple: a main Terraform file and a variables file. Let's go through the variables file first until we have the plan complete, and then we can apply it, and then we'll go back and look through the rest so we save some time. So here are the variables that I've got. I've got a prefix, and this prefix is to help me find my resources in Azure once it's deployed. So I initialize it with samg. Remember, the variables.tf file is a file where you declare all the variables that you intend to use in your code. We also need another file that will show, or that will assign, the actual values to the variables that we're using. When you're using Terraform Cloud, it's recommended to use the variables in the UI, so you can directly write them in the UI, or you can use an API call to Terraform Cloud to push that through. If you use a Terraform .tf vars file, that will get overridden in the cloud. So don't do that. There's a note there. I'll show you what it says in just a bit. So the other ones, the location, we're doing this in Central US. The Spark version, this is the runtime for Spark that we're going to call on. So 7.3x. The node type, DS3 is the default. By the way, this is all defaults, right? So we'll override those, or we can override those as well. The notebook path, we're going to deploy a Python notebook. And then finally, the minimum and maximum workers that we have. Okay, so let's go back here, and we see everything has gone through. The policy check now has completed successfully. So we can go ahead and confirm and let's say all is good, for example. And that will go ahead and apply everything for us. So this takes about 6 minutes. We'll see how we do in terms of explanation. We might have to stop the video and continue once it's done. But for now, let's go ahead and take a look at a couple of things. Let's take a look at the variables that I talked about earlier. So Terraform Cloud allows you to create sort of like a Terraform TF vars file. See, it says these Terraform variables are set using Terraform TF vars file that will run inside of Terraform Cloud. And here I'm just writing the same variables that I specified in the variables.tf defaults. Then finally, the environment variables are important. This is what you're going to use to connect to Azure to create your Databricks workspace and everything else that's needed. So you need a subscription ID, a client ID. Notice the client secret is also known as a password, so it's sensitive. It's write-only, meaning that I can't make any changes once you've written it, and check the box sensitive. What happens is this gets encrypted at rest. It actually uses Vault, HashiCorp Vault behind the scenes. But basically, I can't do anything. I can override it, but I can't view what was entered in here, which makes this very secure, and highly recommend that you use this method as opposed to writing sensitive variables in your own workspace on your own desktop or workstation. Okay. Now, the other thing I want to show you is the policy that we specified, right? Remember, we put a Sentinel policy in place. So you set it here under settings, policy set. It lives in GitHub. Everything to do with Terraform, really, version control system is your single source of truth. So always make sure that you have everything living in your version control system, your repos that tie into the workspaces, but also the policies as well. And the modules, they live in the version control system also. So here I have the option of enforcing this policy on all workspaces or a subset of workspaces. In my example here, I have it under the Databricks Azure Workspace, so I'm only enforcing this policy on this particular workspace. You have also the option to add parameters that could be used inside your Sentinel definitions, and I'll show you exactly where that will take effect. But basically, that's it. That's how you set your policy set that will connect to your workspace. So you create those guardrails for your users. Okay, let's go back to our workspace, see how far we've gotten. I see applying is running, so that's good. Okay, we're about 3 minutes in. So let's go back to our main code and just go through the main.terraform code. First block here is the Terraform stanza, and here you specify the required providers. So Databricks is one and Azure is another one. Always best practice to pin the versions of the providers that you're using. The reason for that is that, let's say a month down the road, you want to run this code once again, or you send this code to a colleague and they run it. And if you didn't specify the version, the latest version of the provider will get pulled in. And there could be breaking changes in that, which will break your code, and you won't be able to deploy this. And you might get errors that won't necessarily tell you what the problem is. So it's usually good to be able to pinpoint or pin the versions of the providers that you're using. All right, so let's go ahead and take a look at the rest of the file here. So I have a provider stanza. There's not much in here because most of the variables or environment variables have already been defined inside of Terraform Cloud to be able to connect to Azure and do things in there. I have a Databricks stanza as well that looks at an Azure Workspace resource ID. And then we got the resource group in Azure. Here's the prefix where I'm going to name this with my prefix so I can always go back and find it inside of the Azure console if I need to. Here we're defining a Databricks workspace. I'm giving it a SKU of trial. There are a couple. I think there's development. I think there's another one for production or premium. I can't remember. You'll find that in the documentation. The other thing is you can specify a user to be used. So here in this case, I'm creating an admin user. You also can create roles for those users. Then we're creating an auto-scaling cluster. And in here, you specify the name of the cluster, the Spark version you want to run on those worker nodes, what type of nodes to be run, and the minimum and maximum number of workers that you'd like when you're auto-scaling. You can also define the packages that you'd like created inside the VMs, those worker node VMs. In this case, I've got two here from PyPy for Python, the scikit-learn machine learning library, and another one here, FBProfit. You can also create tags, custom tags, so department engineering for this cluster. And here is a notebook that you can pre-populate with commands. So in this case, I'm pre-populating this Python notebook with just a simple print command. We'll see how that's going to run. Then you can obviously create multiple different kinds of notebooks. This is just a Python one. And now finally I have a job that I'm creating, and I'm giving it a name, featureization, and some parameters here are defined. You can see the package that I'm using as well inside of this notebook, inside of this job, and if you need notifications as well. So that's it. It's a simple configuration here just to show you how you can automate the creation of a Databricks workspace and a notebook, a job, a cluster, an auto-scaling cluster, even users as well. You can refer to the documentation for more things that you can do. Now, one more thing I would like to show you here before we go back and take a look at how far we've gone in the apply is the Sentinel policy that we define. So here's the policy that we've defined here. You can see some of the parameters that we've defined. So the param max workers default is 5. The other one here, the allowed node types, and here's the list of the allowed node types. So we could have defined these parameters also in the UI as I showed earlier in the section where it says parameters, and that would have gotten picked up from the workspace as well. And all this is doing is checking, again, the number of maximum workers that you are allowing and the type of nodes that you're going to create. Then we call on two things. We're sourcing a tfplan functions.sentinel file here. This is abstracting a lot of the code that that is used to do the check on the plan. And then the other piece here is the policy definition that we've created. This is usually the name, or it should be, it has to be actually the name of the Sentinel policy that you're defining here. And then the enforcement level, in this case, it's a soft mandatory. You can do a hard mandatory. As we saw in the demo, the soft mandatory allows you to override that if you have the proper permissions and privilege. Hard mandatory is going to fail the apply and not allow you to apply your resources. All right, let's go back and take a look at where we're at. So we're around 5 minutes, probably another minute or so to go. So what I'll do is I'll pause the video for now and we'll come back once it's done. All right, we're back. So the apply successfully completed. You can see it added 6 resources here. So let's go ahead into our Azure console and search for what we just deployed. Here's my resource group, and I have a workspace here in Databricks. Let's launch this. And here's our shiny new Databricks workspace. And we can take a look at a few things here. Here's my admin user that was created. And here's the Python notebook that's already created and pre-populated with this command. Of course, I can run this. And it's asking me to attach. So I already have the auto-scaling cluster. I'm attaching to a cluster. So sure, let's attach and run this. Waiting to run. There you go. That printed out nicely. Of course, the cluster we just saw, it's running. It has 2 nodes. This is the runtime from Apache Spark, and the type of worker node that we're using, DS3. Here's the job, the featureization job that we created. It's waiting to be run, so we can run that. That ties into that same Python notebook that we created as well. So once this completes, we'll be able to see the same output that that we just saw. Excuse me. So let's, I guess, go here and come back. There we go. Okay, so it's completed. Here we go. Let's take a look. And there we go. Here's your output. This is the command that was run in the notebook, and here's the output. So the job succeeded. So hopefully this gave you a good overview of how to use Terraform or Terraform Cloud in this case, how to put governance in place and compliance in place with policies from Sentinel to make sure you have guardrails so that developers can follow those policies and not necessarily deploy clusters with a lot of worker nodes or even VMs that are very large. That's not necessarily part of your policy, and if they do need to, they can always get permission, for example, to override the policy. But for the most part, this helps them from a self-service perspective, that they don't need to submit a ticket. They can just go ahead and run the Terraform commands to spin up their Databricks cluster to do their machine learning jobs and data modeling and everything else they need to do without hindering their way of doing that. So I hope this video has been helpful, and I'll catch you in another video.